Hello everyone and welcome to my mini lesson. Today we're going to learn about the four forms of algebraic statements. Understanding the form of an algebra problem helps us know what the problem is asking us to do and how to approach it correctly. In algebra, problems usually fall into one of four categories: expressions, equations, inequalities, or systems. Even though they may look similar, each one has important differences, and those differences matter when we work with them. Before we go over the statements, let's talk about what is algebra. Algebra is a branch of math that uses letters and symbols to represent unknown values. Instead of always working with just numbers, algebra lets us work with variables that stand in for values we don't know yet. Knowing the form of an algebraic statement helps us decide whether we should simplify, solve, or compare. Let's start with expressions. An expression does not have an equal sign, which means it cannot be solved. Instead, expressions can only be simplified. Expressions are made up of numbers, variables, and operations all grouped into terms. Expressions are what you see when you are combining like terms. Here we have an example of an expression and the parts of an expression. Our example says 2x plus 4y minus 9z minus 10 plus q. Notice that there is no equal sign anywhere in the expression. Because of that, we are not trying to find a solution, we are just working with the parts of the expression. So let's break this expression apart. The terms are 2x, 4y, negative 9z, negative 10, and q. The variables are x, y, z, and q. The constant is negative 10 because it does not have a variable. The coefficients are the numbers attached to variables like 2, 4, and 9. Remember, when a number is next to a variable, that means multiplication. Next, we have equations. An equation always has an equal sign, which shows that two expressions are equal. Unlike expressions, equations can be solved because we are looking for a value that makes the equation true. The example that we have for equation here is x plus 3 equals 10. Our goal would be to find that the value of x that makes both sides equal. Since there is only one equal sign, this equation has one solution. Now let's look at inequalities. Inequalities use symbols like greater than, less than, or equal to, less than or equal to, greater than or equal to. Okay? Instead of saying two expressions are equal, inequalities compare them. Because of that, inequalities usually have many possible solutions. So let's look at this example. We have x plus 3 is greater than 10. So in this equality, any number can be placed with the x that makes the statement true. For example, if we place an 8 in place of that x, we would get 8 plus 3, which equals 11. 11 is greater than 10, so that would be true. There isn't just one value that works. There are multiple values of x that would make this statement true. The last type of algebraic statement is called a system. A system is made up of two or more equations that use the same variables. The solution to a system must work for all of the equations at the same time. So let's look at this example here. We have y equals 2x plus 3 and y equals 10 minus 4x. To solve a system, we are looking for values of x and y that make both equations true at the same time. Now it's your turn to practice. Look at each algebraic statement and decide whether it is an expression, equation, inequality, or system. As you work, pay close attention to symbols like equal sign and inequality symbols. They are your biggest clues. Before we wrap up, let's go over a quick summary of what we learned today. So, expressions have no equal sign and cannot be solved. Equations have an equal sign and usually have one solution. Inequalities compare expressions and have many solutions. Systems are made up of multiple equations that must work together. Knowing the form of an algebraic statement helps you decide what steps to take next and what you are looking for.